odds, they are different. Okay. Now I can do a really quick 2 examples when we're done. I think I should do a little more explanation than that because I know we have some people who struggle with this issue. Okay. So let's just make sure we understand our vocabulary. Outcome. Really, that just means you're looking for one possible result. Okay? And it's important that you understand there's one possible result. Meaning, you put your hand in a bag of 10 red marbles, you're not, and you're trying to figure out the odds of, or the probability of pulling out a red marble. The outcome is you're still only pulling out one marble. Okay, yes, it's 100% that you're going to pull out the red one, but you're not pulling out all 10. You're only pulling out one. That's important to keep that in mind when we do multiple things. Well, there's 13 clubs and a deck of cards. Why wouldn't it be 13? It all depends on what it is we're looking for, okay, and what you're pulling out. Did you pull out 13 cards? No, you only pulled out one. Yeah, there's 13 possible to pull out, but you're only pulling out one. And that's kind of important that you get that from probability, okay? All right, the event. That would be all possible results. So the outcome I have on here, if we have dice, if you roll the dice, there's 6 possible things, but you're only going to have one that shows up, right? Only one face that comes up. For an event, for dice, if I wanted the evens, how many are there?
There are 3.
Yeah, there's 3. All right. Okay, sample space. That's the set of all outcomes. That's the total. Total of everything. I'm not even going to say the right thing. So let's just say the total of everything. All right. So really a probability is the event divided by the sample space. That's what it comes down to, what probability is. And then you actually have your obvious outcomes whenever you do the experiment or do the actual activity. So example 1, this is going to be a little writing here. How many outcomes are there? With flipping a coin and picking between 4 shirts to wear. Picking 4 shirts to wear. So it's asking possible outcomes, yes?
There are 8 of them.
Okay. How'd you get it?
Multiplied 2 times 4. There's
Okay.
2 outcomes for the coin and 4 outcomes for the shirt.
Yeah, so this is called the counting principle. So what this example is doing is teaching you how to come up with the total number of things, outcomes that you can have, okay? So, a couple ways to look at it. How many different possible outcomes are there for the coin?
2.
What are they?
Heads and tails.
All right, heads and tails. How many shirts
4.
So let's say you picked, or you flipped a coin and you got heads. There's 4 different types of shirts. A, B, C, D. Okay? So you have heads and shirt A, heads and shirt B, heads and shirt C, and heads and shirt B. 4 possible on the one, and the same thing for the tails. Except for the tails. Tails and shirt A, tails and shirt B, tails and shirt C, and tails and shirt D. 8 possible outcomes. So if you only had 2 pairs of pants and 4 shirts, you'd have 8 outfits.
Oh.
Okay.
That's not like, what are y'all?
All right, so here's the counting principle. You take what's possible in each subject that you have and multiply them. So there's 2 possible outcomes here, there's 4 there, and 2 times 4, that's 8. And that's what you have here, 8 possible outcomes. That's the counting principle. Multiply the 2 together or however many events you have. Okay? Alright.
And that's the sample space?
Yeah, that's the total possible things, yes. And what's, just in general, what, now that you can see it, what's the possible, or the probability of getting heads on a coin and shirt A?
1 in 8.
Yeah, there's only 1 out of all 8. 8 was the sample space. Okay. All right. So example 2. I think you guys grasp probability in general. Let's talk about experimental probability. And considering this is March Madness.
Yeah.
Yeah.
Oh, I figured out what the probability of getting the purple bracket is. And it's very small.
What is?
Okay, experimental probability.
To say the least.
Basically what you're doing is you're taking the actual evidence you have and you're using that to say what's going to happen. So it's almost, I like to call it future probability. Okay, the probability that somebody's going to make a free throw. Well, if you watch basketball, they're giving you probability all the time, or his percentage.
Yeah.
And that's all probability. You know, he's 80% from the free throw line. Well, 8 out of 10 shots he'll make. So they're assuming, you know,
He'll make
his
it.
next shot, he's highly likely to make it. Not that he will. We don't know that. That's why I call it future probability. Experimental probability is talking about what is possible. What I'd like to do with this one is use what we've been doing all year. We keep track of the drive-through, and our sample space is 276. That's the total amount, right? Gone through your drive-through 276 times. So this is how we would write this. I want to know the probability of a correct order through the drive-through. So that's probability notation. And as we go through the next few sections, I'll add to this. But in general, if you see something like that, it's just what's the probability of getting it correct? Okay? And experimental probability means I'm going to go to the drive-through tonight. I want to know what's the probability that they're actually going to give me a correct order. Well, based on what we've been taking all year, the correct that they've done so far is 206.
207. There's
Well, I'm not counting with. So we have 206 out of 276. That's the probability, and then you reduce it.
Is that what you've been?
Just for today's lesson. But I thought it was great if we could use it for today's lesson. I really wanted to know because I think it's absolutely atrocious that they have anything greater than 3% failure rate. Somebody divide this and tell me what you get.
36%.
Yes? Alright, so this is approximately
Don't go to McDonald's.
75%. Actually, that means they fail 1/4 of the time.
That's horrible.
Well, they always fail.
That's why
You don't go there.
everybody hates the drive-thru.
I like
Everybody
it.
goes to the drive-thru.
One in
One out of every 4 cars
Fail.
gets the wrong order.
That sucks.
Yo, I ordered chicken nuggets and I forgot to give me sauce for it.
That's
That's incorrect. It's wrong. That's
I get chicken sandwich and everything.
yeah. Okay, so experimental probability, that's what it's used for.
that's
And
good.
you know, I guarantee you, the powers that be in these fast food restaurants know exactly what this number is for each individual store. Okay? They know what it is. Everything is timed down to the last second. Now, they may not know whether or not you got the order right, because the only time they know if it's wrong is if somebody comes in, tells them, and somebody keeps track of it. How many managers do you think are actually going to write down that they screwed up an order? Okay, so what do you think the powers that be think is the correct answer?
Like 90 something.
I bet you they think it's 98%. It's nowhere near that. It is absolutely terrible.
Send that in.
Everybody in here knows, without me even doing this, this year, knows that the drive-thru screws up your order. It's because it's terrible. It is absolutely terrible. Yes.
Yeah, Subway.
Well, that is a little different. It's variable. It's changing. With the drive-thru, it's exact. You tell them what you want. We'll see. Either give it to you or they don't. Okay. So, for experimental probability, you can give me the percentage. That's right. Go ahead and look at the back of the book for your odds, just to see what they're doing, so we can all kind of be on the same page. But if you leave it as a fraction, you have to make sure it's reduced. Okay.
Do we give
25% failure rate's unacceptable. Nobody should go to those fast food places.
That's at McDonald's.
Because
Subway's actually good. They actually, yeah, Subway's
I've never gone through drive-thru Subway.
Hey,
I've never done it.
I go inside.
Yeah, why don't you go inside?
Mr.
You know why I
Walker.
go inside? Because I want to watch them handle my food. I can't do that at McDonald's.
Dude, we,
Oh, I mean, other places.
My brother worked there.
Or Burger King, or
They've been sold
Wendy's.
out of chicken fries.
I
There's this guy was being really mean to him. So he started spitting his sandwich.
Oh, yeah.
Mr. Walker.
Yeah.
Do you want us to put it in dialogue form or percentage form?
I want you to, everybody do the same, just look at the odds at the back and see what they're doing. The experimental probability, usually we're talking about percentages, okay?
Okay.
If we're talking about stuff like this over here, it's going to be fractions. Oh, they did?
Yeah.
Leave them in fraction form.
I just found this one.
Alright, I want to talk about odds. And we're going to use the same example here. How many incorrect are up there?
70.
70. Alright, so correct we have 206, incorrect we have 70.
Yeah.
Odds would be in favor. So, in favor, we'd say the odds of getting a correct order is 70 to 206. What's the difference between this and that one? What's the difference between this one and this one up
Oh,
here?
I know.
Oh, I'm sorry. Sorry.
Mistake.
206. I caught it. You didn't. There. Now, tell me the difference between this one and this up here. So this was the probability of getting a correct order. This is the odds in favor of getting a correct order. What's the difference?
The experimental probabilities out of the total, and then
All probabilities are out of totals. Yes.
and each out of those the
Yes.
correct.
Yes.
Correct. Because the odds is the incorrect or the correct or the correct.
Right. Right. There's not a total here. As far as has the total of everything, incorrect and correct. This one does not do incorrect to correct. Against, what's the odds against?
Incorrect.
70 to 206.
Yeah, just switch it. 70 to 206. That's as simple as it gets. Okay. Yes.
So is that like a ratio? So it'd be two?
Yeah, you can write it as a fraction.
Yeah,
Or can we put a colon in between 14?
Yeah.
that's a ratio.
That's what I got.
Yes.
When we put it in a fraction, we put the 206 over the 70.
Yes. First one always over the second one. Same thing when you're reading it in a story problem. When it talks about the quotient, it's always first over the second. Your assignments.
You made this long.
846, 1 to 16.
I died.